In the last video, we looked at graphing y equals absolute value of f of x, which involved reflecting what is below the x-axis above the x-axis. We also looked at another type here, y is f of absolute x, which involves leaving what is to the right-hand side of the y-axis and then reflecting that in the y-axis. Okay, effectively deleting the original left hand side of the y-axis and reflecting the right hand side on the left hand side. The third type, we haven't looked at this one yet, we haven't done examples, involves basically, it's very similar to type 2, it's just we're switching x and y, right? Instead of taking absolute value of x, we're taking absolute value of y. So, unsurprisingly, just like type 2, it involves a deletion and a reflection. Except instead of doing things in relation to the y-axis, we're actually doing things in relation to the x-axis. So we're going to delete any sections of the original graph below the x-axis, and then leave what's above the x-axis and reflect what's above the x-axis below. Alright, so that's what this type is. Let's kind of look at the definition, try and understand it a little bit, and then we'll do some examples. So, the first thing to probably note is we know absolute values must be positive. So obviously this graph here won't exist when f of x is negative. Okay, so since absolute value of y is positive, absolute value of y equals f of x doesn't exist where the original is below the x-axis. So that means delete the original graph below the x-axis. Alright, and if we use the definition of absolute value, I can remove the absolute value if what's inside the absolute value is positive. Okay, so if y is greater than or equal to 0, I can remove and just write y equals f of x if y is greater than or equal to 0. If what's inside the absolute value is negative, that would become negative y equals f of x. Take the negative of the inside for y is less than 0. And what I've just done is I've shoved the negative over to the other side. So I get y is equal to negative f of x if y is less than 0. The first bit of the piecewise function says that sections above the x-axis remain in the same position. And the second bit can be interpreted as sections below the x-axis get deleted. They're replaced by reflecting the top part of the graph in the x-axis. Alright, so let's have a look at this question here. I've drawn the graph of y equals sine x, and we want to do absolute value of y is equal to sine x. So the key thing is if the original graph is positive, where the original graph is positive, that still stays the same. So hopefully you can see that. I'm trying to trace over the graph there. And then what we do is we take those bits where the original graph is above or equal to the x-axis and we reflect them in the x-axis. So it'll look like this. So we get what looks like, they kind of look like Easter eggs. So Easter eggs. Notice where the original graph was below the x-axis has been deleted, okay? Alright, let's do another one. Alright, mixed examples. So this one here, recall if you got y equals absolute value of f of x, that's f of x if f of x is greater than or equal to 0, and negative f of x if f of x, the inside is less than 0. So that means, so if we're above the x-axis, we stay in the same position. So it stays. And this bit here means if the original graph is below the x-axis, we reflect in the x-axis. So it'll look something like this. And this bit gets reflected above. Okay. That's that one. This is just the type we've just looked at. So remember, for this type, this is absolute value of y. If we are above the x-axis, we stay in the same position. And we reflect that in the x-axis. So it's going to kind of look like a hexagon type shape. Okay. Next one, combining multiple absolute value transformations. So the way we do this is I recommend just doing one transformation at a time to help you work out. Just important that order matters if there's an absolute value of y. If there's absolute value of y, sketch that bit last. Okay. So basically type 1 and 2, if it's only type 1 and type 2, so if you're trying to sketch y equals absolute value of f of absolute value of x, order actually doesn't matter. It's only when there's an absolute value of y. So if you have absolute value of y equals this, do this last, okay? Or if you've got absolute value of y equals absolute value of f of x, like that, do that last. Okay. Yeah, focus on the right hand side. I usually do inside to out on the right hand side, and then if there's an absolute value of y, I do that one last. Alright, so here's a sketch. They've sketched this graph here. They want us to sketch this transformation. Notice that x has been absoluted everywhere, and also that the whole function on the right hand side has been absoluted, which means this is a y equals absolute f of absolute x. So there are two absolute values here. Let's just start off with the first one. I might use red or something. So let's draw in red. If you want, you could just draw it, say dotted if you don't have a different colored pen. Okay, so remember, if we absolute x, that means that everything to the right hand side of the y-axis stays the same, and then we reflect that in the y-axis. Okay, so that's the first graph there, and then what we're going to do is we're now going to take absolute value of that, and I'll represent it by green, and that'll be the final graph. Remember, if you take absolute value of the right hand side, anything above the x-axis will stay above the x-axis. Anything below the x-axis gets reflected above. So the final graph is the green graph here. Alright, next one. Alright, so we've got, let's have a look. What have we got here? So this has got the form absolute value of y, and then we're doing the absolute value of the right hand side as well. Okay, so the first thing to realize is that we have to do this bit first. So let's do, I might use red. Let's do y equals absolute f of x in red. So remember, if we do absolute value of the right hand side, we are doing anything above the x-axis remains above the x-axis, and anything where the function had negative height gets reflected above the x-axis. So it looks like that, what I've drawn in red. And now maybe I'll go a different color. Let's go blue to draw absolute value of y is equal to absolute value of f of x. Okay, remember that if I'm doing absolute value, of y. It only exists where the original function is above the x-axis. Now the original function here is the red one, or I'm looking at the red function. I'm going to take that graph, draw everything that's above the x-axis, and then reflect the whole thing in the x-axis. So hopefully you can see it's going to look like that. So it's got a little infinity kind of sign in the middle, and it's got 4 curly tails popping out the outside. Alright, what I'd like you to do is do the Cambridge exercise 5e on page 7 of the extra exercises. Okay. Homework will be to finish off, just finish 5e and do, I think it was 3.3, right? 3.3 and 5e is your homework. Alright, hopefully see you tomorrow.